Hello, everybody. 4.1 and 4.2, right triangle trig and degrees and radians. 4.1 should be pretty much a review. Hopefully you've done all this stuff in 4.1, which is why we're combining both, okay? And they're both not terribly difficult topics. So without further ado, your six basic trig functions right here. Hopefully you recognize, hey, sine is opposite over hypotenuse, adjacent over hypotenuse is cosine, and tangents opposite over adjacent. And then the reciprocals are over here, right across from each other. And then over here, above it, I got a triangle as a reference point. So we have theta, whatever side is facing theta, that's your opposite. Adjacent is the other side, and then the hypotenuse is the side opposite of the 90. So go ahead and pause, copy it down. So here's our first example. I have a triangle over here to the right. I want to find the exact values of six trig functions of theta. So sine opposites over hypotenuse, so that's going to be 33 over 65. What's nice is the cosecant is reciprocal, so we just flip it. 65 over 33. Cosine theta, adjacent over hypotenuse, so 56 over 65. Then flip it for secant. Tangent, opposite over adjacent, so 33 over 56. And flip it for cotangent, 56 over 33. Another example here, if sine theta is equal to 1 over 3, find the exact values of the find remaining trig functions for the acute angle A. So one thing right away, it should be angle A, it should be theta. Secondly, one thing you should rattle off right away is its reciprocal. So cosecant theta is equal to 3. Just flip it, 3 over 1, it's 3. Next, I can't find the other two trig values, so we'll say theta is there, right angle's there. So sine is opposite over hypotenuse, so we know the sides are 1 and 3 there. I don't know what the adjacent is, so we have to do Pythagorean theorem. So it'll be 1 squared plus b squared is equal to 3 squared, giving us, do the basic algebra, b will be equal to the square root of 8. So now we can find the other 5 trig functions because we have all of our information now. So we get root 8 over 3 for cosine theta, which means secant is equal to 3 over root 8, but we need to rationalize, so it'll be 3 root 8 over 8. Tangent is opposite over adjacent, so that'll be root 8 over 8. Once again, rationalize, please. Cotangent theta, flip it. You just get root 8. For circumstances where it's a 30, 60, 90 or 45, 45, 90 triangle, we can find the six basic trig functions for 30 degree, 45, and 60 degree angles quickly and easily, okay? You should know these like that. Boom, quickly. And all of these values I found right here is based off of these two triangles and their ratios up here. So keep that in mind when you're solving. Time for finding the missing side and missing angle measure. So in this case here, um, two things I'm going to worry about. One, stick to sine, cosine, and tangent for doing these problems, please. Okay, stick to those three. It'll make your life easier when you're doing these. Secondly, make sure your calculator is in degree mode. Okay, I'm going to be preaching this chapter, the next chapter a lot. Make sure you're in the right mode. Okay, if you're dealing with radians, be in radian mode. If you're dealing with degrees, be in degree mode. Please make sure you're in the right mode. Right now, you should be in degree mode. If you need help figuring out whether you're in degree or radian mode, then make sure you ask me in class. So first, we got this angle 35 given to you, right? We have x, which is the adjacent. We have 7, which is the hypotenuse. So we have adjacent hypotenuse. Which of the three basic ones is it going to be? If you guess cosine, you'd be correct. So cosine of 35 degrees is equal to the adjacent, which is x, over the hypotenuse, which is 7. Multiply both sides by 7. 7 cosine of 35 degrees is equal to x. What's that equal to? Well, that's going to be equal to about 5.7 is equal to x. Next, finding the missing angle measure. So we got opposite and hypotenuse. Which one is that? You're right, it's sine. And opposite is 12, hypotenuse is 15 over 7. So in order to get this by itself, we have to do an inverse sine function. Okay, so whatever this is right here, you're going to do its inverse. Okay, so it's going to get theta equals, you're going to go in your calculator and say inverse sine, which is basically just going in your calculator and clicking the second button, then the sine button. Plug that in. And what do you get? You get 50 degrees. There's your answer. All right, word problems. So make sure that you're reading these word problems carefully. Skiing. We're talking about skiing here. The chairlift at a ski resort rises at an angle of 20.75. So it's rising 20.75. So it's going up 20.75. And while traveling up the side of a mountain, attains a vertical height of 1,200 feet. So that's 1,200 feet. When it reaches the top, how far does the chairlift travel? So where's the chairlift traveling? Right here, right? That squiggly line right there I made. Okay. So we know this angle right here is 20.75. We know its opposite is 1,200 feet, and we want to find the hypotenuse. So which trig function should we use? You said sine. You were a smart person. So sine of 20.75 equals opposite 1,200 over hypotenuse, which is h. So when we want to solve for h, it's going to be 1,200 over sine of 20.75. Put that in your calculator, you will get approximately 3,387.05 feet. That's your solution. Now let's talk about angles. So this is the 4.2 portion of your video. So let's talk the basics about angles, right? It's two rays that meet at the end, right? So when we talk about angles, there's a few basics, right? We have an initial and terminal side, okay? The initial is the side that doesn't move. Okay, the terminal side I can move all around here to form the angle, okay? And where they meet right here is it's called the vertex. Here, once again, this is on a coordinate plane, which you're going to see a lot of in this chapter and the chapter after. So initial is usually going to be right here just about at every moment. And then the terminal is the other one that's moving around. Okay, I made a terminal right here. Once I guess at what the angle is probably going to be about? If you said something between 90 and 180, you'd be right, because in your corner plane, this is 90 degrees right there, right? And if it goes a little beyond 90 degrees, right, but not beyond that, we're down in this quadrant, you're going to be between 90 and 180. The other thing, with positive and negatives, okay? You go in counterclockwise, it's positive. Going clockwise, it's going to be a negative angle, okay? That's how it works. So, angle, right? So, positive on the left, negative angle on the right. EMS 2 degrees and vice versa. So if I'm giving you degrees, Another way to write degrees is in what's called DMS, degrees, minutes, seconds. You might see this a lot if you're going to be a pilot one day, right? Sometimes they use these as far as coordinates go. So first I'm given degrees, I want DMS, okay? So how do you do it? I'm going to take whatever the decimal is, okay? So I already know the degree is going to be 329 degrees. I'm going to take the decimal and multiply it by 60. Okay, I'm going to do this twice to my decimal, okay? So when I do that, I'm going to get 7.5. I'm not done yet. What does that mean? So whatever is the non-decimal part is going to be your minutes now. So 7 minutes. And now I'm going to take the 0.5 and multiply by 60. What do I get? 30. That will be your seconds. Okay. Now we're going backwards. Okay, so I have 35 degrees. I don't know my decimals yet. But we have 12 minutes. I'm going to take 12 times 1 over 60. And 7 seconds. 7 times 1 over 6 times 60 is 3600. Multiply them together. You get 0.2 for the first one. 7 divided by 3600 is 0.00194. So that's going to get us 20194. That is what your answer is in degrees. There's another unit we use for measuring our angles, and that's radians. And you might want to think, what is a radian? Radian, in simplest definition, is ratio of the length of the intercepted arc S to the radius of the circle. You might think, Mr. Barton, what is that? That makes no sense to me. And I get it. There's a lot of interesting words here that you may not remember or recall. One of them is intercepted arc, right? This right here, that's an intercepted arc right there, okay, of your circle, okay? So it's not the whole circle, it's part of a circle. Let's say we did find the angle of the whole circle, okay? As you know, one circle is 360 degrees, right? What's that in radians? 2 pi, okay? Now you might say, why 2 pi? Well, think about it. So if I ask you for the circumference, right? Circumference is equal to 2 pi r if you remember right, okay? And we said here in your definition, radians is the ratio of intercepted arc S to the radius, right? So we're dealing with S equals R theta, right? So if theta is equal to 2 pi, that's your circumference formula, okay? So that's where this is all coming from, okay? So if I put 2 pi in for theta, that's going to be everything around the circle, okay? This brings us to converting between radians and degrees. If I give you degrees and I want radians, multiply by pi over 180, okay? There'll be a pi that cancels, or no, not a pi that cancels. There you'll be including a pi, and then simply just simplify the fraction. Here, radians to degrees, 180 over pi. This one pi's will cancel, unless if you don't get a pi in your radians given, that's okay. Then I'm going to just expect your answer to be in decimal form. Let's do some examples. So we have negative 60 degrees and 4 pi over 3. So I'm given degrees, I want radians. So what do? You multiply by pi over 180. We get negative 60 pi over 180. If you reduce 60 over 180, you can take the top and bottom divided by 60. You'll get negative pi over 3 for your answer. This one, you're given radians, you want degrees. So you're going to multiply by 180 over pi. What's nice, the pi's cancel. Also, can we simplify anything else? Well, 180 divided by 3 is 60. So it's going to leave us with 4 times 60, which is 240 degrees. The thing with circles that we're dealing with here is that they can keep going round and round, okay? Because if I say I have an angle right here, I can keep going round and round, folks. and get to the same point again. Okay? And that's called coterminal angles, when you have two angles that have the same initial and same terminal side with different measures. Because the two that I just drew right here, um, they have the same everything else, just different angles. Okay? Let's call these, let's say the red one was 45 degrees, and then the next one was, we had 3/6 that, it will be 405 degrees. An example of a radian would be if, let's say that angle was pi over 4, and as I said before, we are going to add 2 pi. One time around is 2 pi, right? So add 2 pi, and that's going to get you 9 pi over 4. I will do some more practice with this in class. Arc length. The formula is S equals R theta. What do they mean? R is your radius. Theta is your angle in radians. Okay, it's in radians. Important note, if I give you an example of finding the arc length in degrees, you're going to need to change it to radians, or it's wrong. And S, of course, is the arc. Let's do an example. Let's say that I have 135 degrees for your angle, or theta, rather. And we have R is equal to 0.5 feet. Now, find the arc length. So you might be tempted to say S equals 0.5 times 135. And you'll say the answer is 67.5 feet. And you know what I'm going to say? Wrong. Say wrong, 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 wrong. Why? Your angle's supposed to be in radians, so you're going to multiply it by pi over 180. Now multiply that all together. And what do you get? You'll get about 1.2 feet. How's that sound? Sound good? Of course it does. Two more things you're going to calculate is linear speed and angular speed. Okay. Linear speed is v equals s over t. T is time. S is arc length. Arc, time, and v is velocity, or your linear speed. Right. Angular speed. This looks like a W, and it should look like a W. But that's an omega. It's a lowercase omega. Okay, and that's how you write angular speed. Omega, or angular speed, is equal to theta divided by t. Theta is your angle, t is your time again. Let's do an example together. Find the angular speed in radians per minute of a record as it plays. Round to the nearest tenth. Let's say that vinyl record player has a diameter of 30 centimeters diameter, and the record spins at 33 1/3 revolutions a minute. Okay, and we want to find the angular speed. So if I'm given diameter is 30, that means your R is 15, right? And I don't know my theta. How am I going to find my theta? And there is 33 1/3 revolutions a minute. So how many times around a circle is it? That's how many. So we got to multiply that by 2 pi to get your theta. So that times 2 pi will be 66 2/3 pi. So that's going to be your theta. So find, or as a decimal, that would be 209.44. That's going to be a numerator and per 1 minute, right? So it's going to be 209.44 over 1 minute. So your solution is 209.44 radians per minute. That is your angular speed. Area sector, you might want to find areas. Let's say this is your angle right there. You want to find the area of what that is right there. Here's a formula: A equals 1/2 r squared theta. Of course, theta is measured in radians. Make sure you know that. Let's do an example. Let's say that theta is equal to 3 pi over 4. You're in radians. Hooray, we don't have to change it from degrees or radians in this problem. Nice. And r is equal to 1.5. Find the area. So 1/2, 1.5 squared times 3 pi over 4. You multiply that together. What do you get? 2.65 feet squared. That's all. I appreciate watching, and you have a lovely, lovely rest of your day. Bye bye now.